Hello, this is Jixil Johnson from ENGI 1331, Dr. Kota's 10 a.m. class. So for this NAE project, we did the solar energy problem as energy is a key factor in sustainability. Since non-renewable energy sources such as oil, natural gas, coal makes up about 81% of energy consumption in the US alone, and with only a limited amount of it left, renewable energy sources should be seen as a better way to obtain energy. So that is why we chose solar energy as our project, since it has the most potential to produce large amounts and a steady source of energy. In the data based on the energy production of a few countries, each different plant produced different amounts of energy in that country. Even though solar energy is widely used, it is not as quite as efficient as it should be. So it is our goal to compare the usage of within the countries to see the correlation between them, and at last to calculate the annual solar energy output of two different types of solar cells, and to decide on which one is better. Looking at our problem statement, we stated that we would compare megawatts per hour for different countries in the same class using menus and pulling data from Excel and getting the corresponding megawatts per hour the user chooses and comparing them to silicon and CIGS to see which cell would do better overall. The equations that we used throughout the script was the energy equation, which equals out to productive land times kilowatts per hour over day times n times 365 days. Productive land is 1.5% of total land available of that country. N is 10% conversion efficiency. The second equation that we used is the annual solar energy output equation, which equals out to A times R times H times PR. A in this case is the total solar panel area, which is the total amount of land the solar panel is laid out on. R is the solar panel yield or the efficiency of that certain type of cell. H is the annual average solar radiation, which is different for every country. PR is the performance ratio and coefficient of losses. First thing that we did was did XLS read and importing the Excel file. The second that we did was create a menu function and ask the user which country they want to get the maximum year of and gave them options of Afghanistan, China, and Antarctica. If the user selects Afghanistan, it will run this if statement, which would go through data, first row 1 through 7, and first column, which is the data indicated in yellow, and it would get the maximum of that data. And print it using an fprintf using one decimal place. If the user selects China, it would run this if statement and go through 8 through 14, first row, maximum of that, and so on for Antarctica. The next thing that we did was get the minimum of those countries. If the user selects yes, we would go through the second menu and ask the user to input which country they want to get the minimum of. So if they press Afghanistan, it will run the same code, but instead it will be minimum instead of maximum. And so on for the next two countries. The next thing that we did was to get the average of those countries. And instead of minimum and maximum, we would do the mean of those functions, which is the mean of all of these functions, 1 through 7, divided by 7. And we would do the fprintf to portray the answer on the command window. And so on for the next three options. Next thing that we did was to create a subplot of all three figures of China, Antarctica, and Afghanistan in one figure under subplot. So we would create X label as class number and Y label as the data. So we chose class numbers 1 through 7 and data as the plots as the data from the Excel file. So the next thing what we did was to ask the user which country they want to get the energy usage calculation of. So for this, we created a if statement within a function. So what we did was if the user selects 4 for which class they want, it would go through data 2 to 4, which is for Argentina, and get the minimum of that, which is from 2 to 4. The minimum of that is going to be 4, which is corresponding to the answer they gave. The next, if they press 2, which is for 5, it will go to data 2 to 4 and get the mean of that function, which is 4, 6, 5. Mean of that is going to be 5, which is going to correspond to the answer they chose. Instead, if they choose 6, it's going to go to data 2, 4, 4 and get the max of those functions, which is going to be 6, which is the correct corresponding number to the answer they chose. So if the user selects 1, which is Argentina and 4, it will go to this function and pull up these numbers. Instead, if the user selects 2, which is Ireland and 1, it will go to Ireland and 4. And same for US. And we call the function using x equals 1. So if the user selects 1, which is 4, at class number is 4, it will go to data and 85, which is going to be 5. 8 file is going to be 4. So it's going to pull up this number as the class number, and it's going to ask the user to input the number of days, conversion efficiency in percent, and productive land in percent. And we gave the default as 365, 0.10, and 0.15 as indicated in the data sheet. And the answer they gave out was as a string. But we cannot have strings in the command, so we had to use string to number of each of these numbers to get the answer, so we can multiply them in the function. So in the function that we called here, E equals energy, with all the inputs and the output right here, we went to the function and we create a function E equals energy with all the inputs and put in the formula. So as the user inputs all these numbers, it will go to the function and calculate the number of energy of that country. The next thing that we did was to create a polyfit function of all of those countries, Argentina, Ireland, and United States. For this, we asked the user, which country do you want to get to see the polyfit of, Argentina, Ireland, or United States, as you can see here. If the user selects Argentina, it will go to data file, pull up the first three codes, first three class numbers, and pull the data from data 11, 14 through 16. And I created this as a row vector to correspond to the to the class vectors. So I did a power fit for this function. So if we press Argentina, power fit of Argentina will be shown. Same thing for country 2. If the user selected Ireland and United States, it would go to this if statement and go to country 2, and the same class but different data this time. And I would did an expo fit for the second one and an expo fit for the third one as well. And at the end, we polyfit every single graph to see the corresponding data for each of the country. Next thing that we did was to create an integral of all the polyfits using min as 1 and max as 50, calling the function here as integration with all the inputs of all the subplots and the polyfits as IBC, and we go to the integration function, and we did a function for the exponential, and the power fit. So F4 is Argentina, F5 is Ireland, and F6 is United States. So after that, it would print each of the curve under Argentina, under Ireland, and under United States in the fprintf in the command window. The last thing that we did was to compare the silicon with CIGS, which is a thin film of solar cells. From research, we came to the conclusion that a thin film solar cells are better than regular first generation silicon type solar cells, as thin film uses less expensive and easier to work with substance and can be made with the lowest cost manufacturing technique, known as monolithic integration, or MLI, which is producing exceptional efficiency better than the silicon solar cells. For this, we displayed a menu and asked the user to input which one they want to calculate the energy of. So if the user selects silicon, it will run this code and prompt the user to enter the value for A, R, H, and PR. And we gave the default number as 20.4 for our silicon, as it was the efficiency of silicon in 2015. And 2600 is the amount of radiation in Saudi Arabia, as we were using Saudi Arabia as a default. And 0.75 is also default for all the PR. Since the answer is in a string, we have to convert it to a number using string to number of each number A, R, H, PR. For this, we also used a function of solar energy and called this function, which is especially for silicon and especially for thin film. For this function, we plugged in the formula E equals ARHPR. In the end, it will result in an fprintf giving 0 decimal places of E5, which is the annual energy of silicon. Do the same thing for the thin type cell solar cell, which is known as CIGS if the user inputs A, R, H, and PR. In this case, R is 20.8 as in 2015. The value of efficiency of thin type cell was 20.8, which is zero point 0.4 larger than silicon. And we're using the same default as in Saudi Arabia as 2600 radiation and 0.75 PR. I'll demonstrate this whole code right now. Right now, we'll be going over the whole code. Please choose a country you want to get the maximum year of. China. Maximum year portrayed in the command window. Please select a country you want to see the minimum of. Antarctica, portrayed in the command window. Select a country to see the average of. As you can see in figure 1, all the plots are plotted together in a subplot of China, Antarctica, and Afghanistan. Next is the function of energy calculation. Any class. The correct number is 365.10.15, but the user can input any number they wish to input, thus increasing the energy efficiency of this country. Which country do you want to see the polyfit of? As you can see, after the polyfit, the system gives you all the subplots of China, Antarctica, Afghanistan, United States, and Argentina to let you see which graph is extending throughout the class of the period. Underneath is the power fit function of Argentina. Next is the calculation between silicon and thin type cells. If the user inputs silicon, they can input the area of the land the silicon is going to be covered, which can be any number. Once press OK, the energy efficiency of silicon is 49,10814 kilowatts per hour. Is a calculation of CIGS. Going through the same thing, after inputting the same numbers. This shows that when the area of land is extremely large, the change in efficiency is a big factor in outputting the best results. This calculation proves that thin film cells do better in the long run than absorbing sunlight and storing them for usage, which is why we chose thin film solar cells over silicon over cells. And this command window, the energy efficiency of silicon is 4900, while the energy efficiency of CIGS is 507,13200, which is significantly larger considering how much land you're inputting the solar cells on. Engineers can use similar method in this code to explore data sets such as this one presented in this problem. By exploring a similar method and reasoning, engineers can develop and compare plants and use the characteristics and ideas implemented in those plants to help them bring the production of solar energy in those plants that may not be producing as much and helping them reach their full potential. A limitation seen in this is that it was not very possible to input every single country and every single plant that was available. That could have made the production a little better and more precise answers.